Hello, everybody, and welcome once again to another episode of AWS Show and Tell, where every week we bring you some of the coolest things that our teams and builders here at Amazon are working on. My name is Trevor Spires. I'm a solutions architect here at AWS. I'll be your host for today. And lucky for you, I'm joined by two amazing guests from our Amazon AI, ML, and AGI org. I won't steal their thunder. In fact, let me bring them up right now and let them introduce yourself. We've got Anupam and Karan from who are working closely with on the team whose subject matter will be the focus of today's episode, Amazon Nova. Take it away, gents. Tell them who you are, and we'll go ahead and get right into things.
Hey, Trevor, and thanks for having us. My name's Karan. I'm a product manager on the Amazon Nova service team. Specifically, I focus on model customization and looking forward to the rest of the conversation today.
Awesome. Hi, everyone. This is Anupam. I am Senior Solutions Architect, again, in the Nova team, and here to basically tell you all about what we launched. Yeah.
Amazing. And folks, why don't you let us know where you're tuning in from today? I'm coming in from the greater Boston area, but one amazing thing about these shows is we have folks from all across the globe. So whether you're on LinkedIn or any of the live streaming locations, go ahead and let us know in the comments where you're dialing in from. Where are you two gentlemen coming at us from today? Where does Nova live?
I'm actually in Boston too. Maybe we should have done this together in person, huh?
You're right. I probably should have thought about that.
Yeah, I'm joining from Seattle, and I think Nova is spread across the country. So, but yeah.
That's right. Like everywhere all at once. Love it. Love to hear it. Well, today's an exciting topic for me. I'll say particularly, I have customers that are really excited about this particular topic, which is customizing models, right? How can they take an existing model and make it smarter, or how can they make their application run faster? Leveraging some techniques to customize models. So I know so much came out at New York Summit that this is one that folks might have missed between all the hubbub about Kiro and Agent Core. So if you haven't heard this update yet, folks, you need to stick around and learn about all the new stuff's coming out of Nova. So I guess I'll hand it over to you, Karen, to kind of kick us off.
Sure. Yeah. Thanks, Trevor. So, like I mentioned, we focus specifically on customizing Amazon Nova. Through this conversation today, we'll sort of talk about what does it mean to customize, why even customize, and what is sort of the options that we have available with Nova today. So just like at a high level, right? Foundation models are great, right? They're trying to get smarter and smarter day by day, handle more and more capabilities just out of the box. So foundation models are pretty good. But if you want to sort of push the boundaries of what AI can do for you and essentially get to like the 90% plus kind of accuracy levels for your specific business needs, you sort of need like what we call like a domain specific model, right? Now, what does it mean for these models to be domain specific? It's sort of a model that understands your business, understands your domains, understands the way you operate, the way you execute on workflows, the preferences within your organization. So that is sort of what we're going to talk about today in this conversation as well.
It's funny you should say that, because I feel like every time I see a new model come out, I see benchmark, and the benchmarks. I was like, oh my gosh, we're at like 75% on this amazing benchmark. I'm like, okay, that's amazing. So you're wrong 1/4 of the time. So it sounds like this is a path to really tighten up. In fact, I don't know if you'll share any of the data points, but I know some customers have seen some really compelling improvements in accuracy on different areas. So excited to hear more about what you all got cooking.
Yeah, and of course. So just a quick recap as to what do we have in the Amazon Nova family of models, right? So everyone's on the same page, we can start there. So Amazon Nova family of models was launched at reInvent last year. There's essentially two categories of models. One is the Nova understanding models, and one is the Nova generation models. Today, we're going to focus this conversation on the understanding models and the customization options there. So in this series of models, we have the Amazon Nova Micro, the Lite, the Pro, and the Premier. Micro is sort of the smallest, fastest model, which takes text only as an input and produces text as an output. Lite is sort of the next tier of the model there. This is the first and the smallest multimodal model. So it takes text, image, video as an input. and produces text as an output. Pro is the model that's larger and smarter than the Lite. It's a highly capable multimodal model, so it takes text, image, video as an input as well, and produces text as an output. And Premier is the most capable multimodal model that we have for the complex set of tasks that are out there in the industry. What Premier in itself is not customizable, but it is available for distillation into these other models. And we'll get into a little bit more as to what that means as we talk through the customization techniques.
Very, very key to customization as a teacher model, right?
Exactly. Yeah. So just a snapshot of what these 4 models are and where they're at. So we have like a quick glimpse into the context lens, the context windows that are available with these model families, the long languages supported, just a snapshot view of what I already mentioned as like what goes in, what comes out from these particular models, and which of them are customizable, and Premier, as I mentioned, available for distillation as a teacher. Okay, so now getting into a little bit more of the fun stuff that we here to talk today, right? So like customization, right? Why is it important? Why should I care? Why is this person talking, right? So Gartner put out a report earlier this year where they're predicting that by 2027, more than half of the Gen AI models used by enterprises will be domain specific, right? Like so domain specific in the context of specific to an industry or a business function. And this is going to be up from like 1% as of the end of last year, right? Like, so that's a pretty ginormous shift that we're talking about. So this is why customization is important, right? And this is why you should listen to me. And that's why I'm glad. And that's why I'm glad you're here today, right? And hopefully you can take something away from this conversation today.
You showed this stat the other day, and at first, like my reaction was like, okay, who said the stat? Like that seems like a lot. But then I was really reflecting on it, and I think a lot of the recent releases have made me reflect on it more. It's like we're really in this space where it's like it's starting to seem like best case scenario. We're talking incremental improvements, like very small handfuls of percentage improvements as new models release and iterate. And so this makes perfect sense. Like I don't see a path where, to your point, you're going to get to 100% accuracy on your tasks by just waiting for the next state-of-the-art model. I think this is going to be required for those high-fidelity tasks. So at first, I was alarmed, but then I was like, actually, no, this stat makes a lot of sense based on just what we're seeing in the industry right now.
And it's also like going off of what you were saying earlier as well, right? Like when new models come out, we do it too. When we put Nova out, we sort of talk what that means in the context of like public benchmarks, popular benchmarks. But at the end of the day, what really matters to each business is how does this model perform in like my benchmarks, right? On the workflows that matter to me, on the tasks that matter to me. So that's where sort of some of this domain-specific FMs comes in. Okay, so double-clicking a little bit into what it means to have a domain-specific FMs, right? Now, customization is sort of how you produce those domain-specific FMs. It's also how you essentially turn that general intelligence of these foundation models into a strategic business aspect. So when we talk about not being, a general purpose, but being like domain-specific, some of the distinguishes that come as part of that is it's how you capture a unique IP, right? Like every business has the tasks that matter to them, but it's also how they operate on those specific tasks, right? Like what are the decisions they make, what are the actions they take, what are the outputs they produce. These are all usually specific to a particular business. Now, depending on the tasks, like something like a summarization, you might want to, or producing marketing content, you might want to align the responses to your brand's voice, your brand's values. Customization is how you get there. Just even more fundamentally, you may be operating in a domain that requires a lot of specialist knowledge and expertise. Sort of customization is how you provide the model with your domain-specific, just broad proprietary knowledge as well. Just going a little bit along the horizontal capabilities as well. Customization is sort of how you improve accuracy and safety for these foundation models in your domain-specific scenarios as well. And at the end of the day, if you're operating and you're creating an AI-based business, customization is sort of how you create durable differentiation for your business, right? Like if you're using a baseline foundation model to power your business, there's very little differentiation there. So if you're in the business of creating differentiation through AI-powered solutions, customization is sort of how you get there too. So now I've said customization a lot in the last few minutes. Just want to give like some examples as to these aspects that I was talking about from a customization perspective. What does that translate into sort of some real world use cases, right? So think about like a simple prompt, right? Why is my router's LED light blinking? Now, if you're trying to solve for like a customer support kind of a use case, an off-the-shelf model, they're pretty intelligent. They're going to give you like a more of a generic answer, being like, blinking red light usually means there's some sort of an error. Have you tried turning it off and on again? You might want to try restarting. You might want to contact customer support. Now, if you are that business that is sort of providing customer support for your product, customization is sort of how you can automate some of these aspects by training models that understand how your devices operate and how your support operates, right? So you can customize these models to sort of get those level of details and produce more bespoke responses that are nuanced and specific to your business and give actual responses in these specific scenarios. So for the LED light blinking, it could be, okay, so for this red, green, red blinking light pattern, here's the root cause, here's what you should do, and here's the action, and here's the outcome that you should expect. So those kinds of more refined responses for your specific product comes through customization. And it's not just about support, right? Like it applies through every industry, through every use case in that particular industry. So say you're creating like marketing content, you might have preferences as to what you want this content to look like. You might have preferences as to what you would want this content to not look like. Those aspects you can use, tune these models to understand the behavior that you like, the kind of outcomes that you like, and sort of and use AI to sort of create that kind of content. Even going into specialist domains, be it legal, healthcare, financial analysis, they say the example that I have up in front of you here is, you might be creating a summary, or you might want to use AI to create a structured report. So you can fine tune these models and customize these models to sort of show that what kind of outputs and structures that you do like to see for your report, so that when you're automating it, you can get closer to a more, shouldn't say deterministic, but closer to a more predictable outcome as to what these outputs from these models would look like when you are trying to create workflows using it for structured reports. So now we've talked a lot about why customize, what does it mean to customize? So coming back to a little bit of what we launched at the New York Summit. So we essentially launched the most broadest suite of customization capabilities that are available with any proprietary model family in the industry on AWS with Amazon Nova. Essentially, what we're trying to do is we're trying to enable organizations, be it enterprises, startups, or any other organization, to build AI, build AI their way with Amazon Nova on AWS. So along with that, like from why do that, there's a few different reasons. So one, as I already mentioned, what we launched at the New York Summit is the most comprehensive suite of model customization capabilities across Amazon Bedrock and Sagemaker AI. When we do make these capabilities available, we focus on the developer experience as well. So we've done so with a simplified setup and a unified experience such that you can customize these models on Sagemaker, import them within one click into Amazon Bedrock, and sort of integrate with the rest of your ecosystem as well. Responsible AI is an important criteria for Nova. So when you do deploy these models on Amazon Bedrock, it comes with built-in responsible AI considerations, but it also integrates with things like Bedrock guardrails, agents that you can sort of use to build out your application as well. And most importantly, why customize Nova is when you do customize these foundation models, when you do customize Nova, we did launch on-demand inference as well on Amazon Bedrock, supported for Nova at the New York Summit. And essentially what that means is now using these most comprehensive suite of capabilities that we put out, you can build AI your way using Nova on AWS, but without losing out on the inference performance and the industry-leading price performance of Amazon Nova. So essentially now you have an AI that is a specialist in your specific domain and business, but still operating at the latency and cost profile.
This is incredible. Like this is this is the first I've heard of anything like this, right? Where in fact, so just to contextualize this for the people that are watching, today most typically when you fine tune a model, like you have these model weights, and the next step is like, where do I host that? You put it on a container or some cluster of GPUs, or usually it's expensive compute, right? Especially when we're talking about large models. And what this allows you to do is get the same pay-as-you-go economics for custom models on AWS as you get for on-demand models, right? Where folks are probably familiar with the typical structure where it's tokens in and tokens out based billing. So you can do that, like as I understand, you can do this with customized versions of Amazon Nova, which is wild because Amazon Nova is already super inexpensive compared to the rest of or just benchmarked against similar performance models, and so I feel like this will lead to a lot of additional optimization for customers that are using it.
Right, exactly. Okay, so now getting a little bit into like what are the options for customization and a little bit on when to use what kind of technique. So I think RAG has reached a point where it's pretty popular now in the industry. A lot of people are going to production with it as well, and it is great, right? So RAG is almost like an inference time customization option if you want to think about it, just at a very high level. But essentially, what you're trying to do at that time is like you're not actually customizing the model, but at time of producing inference, you're sort of equipping it with additional knowledge and information so that you can like, sort of boost the accuracy based on the latest information, the latest knowledge to produce those kinds of outputs that are needed. But once you move beyond RAG, that's when you're getting into actual model customization. And essentially, you can think of it as 3 stages of model customization. And these stages line up with the foundation model building stages as well, right? So if you think about the development of these foundation models, there's a pre-training stage, then there's a fine-tuning stage, and then there's an alignment stage, right? And within alignment, there's a few different techniques that have been used in the past that are used right now. And as these models are evolving, new and new techniques are coming out as well. But just essentially, it goes across like the pre-training stage and the post-training stage, if you may call it so. But on the post-training side, it's sort of fine-tuning and the alignment. So as part of making available the most comprehensive set of customization capabilities for Nova, we've essentially provided avenues for customization using any of these stages, right? Like, so what it means is, depending on the problem you're trying to solve, depending on the data that you have at hand, depending on the volume of data that you have at hand, you can sort of use a technique that is right for your specific use case to achieve the kind of results that you need across the model development lifecycle. So we're getting a little bit into when to use what. So a step up from RAG, you can think of it as alignment. Now, alignment is going back to the marketing example that we talked about a little bit earlier. The model kind of knows how to do the task that you're interested in and trying to get the model to automate that specific task. But you may want to sort of tune the behavior a little bit. So in that kind of case, you use techniques in alignment, from alignment, where you're essentially teaching the model what are the kind of outputs you prefer and what are the kind of outputs you don't prefer. So almost trying to tune it and optimize it towards that specific direction. But at the end of the day, it still kind of knows how to perform the task. So you could try alignment for something like that. Next step up, like going further up the model training lifecycle, is what we call like supervised fine-tuning. Now, in supervised fine-tuning, you're essentially training the model with specialized knowledge. So what this means is now you may want to actually tune the way it does a specific task as well, or it may not do a task at the kind of accuracy levels that you need it to, right? Like, so if you're trying to push the boundaries of 90% on a task, which the model isn't really good at just as yet, you could use something like fine-tuning to sort of boost performance over there in itself. So think of this as, when you're talking about your business-specific workflows, how your business operates, how it specifically does tasks, this is where you could use something like a fine-tuning. This is the avenue to almost capture your business IP as to how your business operates and sort of teach the model to be able to do that as well. Going further a step up, if the model in itself needs a deeper domain understanding, you may have a lot of data that is your IP data or your proprietary data that is available to you. You may want to teach the model just that broad, general domain knowledge. You could use something like a continued pre-training to be able to do that. While alignment and fine-tuning use more of what you can call like labeled data. In the case of alignment, it is with preferences or what you kind of thing you prefer, don't prefer. On the fine-tuning side, it's kind of like a sample in, sample out kind of a label data. In pre-training, it's more you're just teaching it domain knowledge. So it's a lot of unstructured data, no labels, where you're trying to just teach the model domain-specific core capabilities in itself.
Now, I mean, I've got a kind of classic question for both of you gentlemen, which is like, where I guess. Where do you answer the question of where to start, right? In terms of these the sliding scale of customization options? I know my answer, but I want to hear what you tell customers when they ask.
Yeah, I mean, I can start, and Karan, feel free to chime in. But like my recommendation is like, if it is really a new field or a new concept that you don't think a generic LLM would know. So, for an example, a proprietary knowledge about your business, which is very domain specific, which LLM may not know, and you have a decent amount of data, and by decent I mean billions of tokens of data, then go directly to CPT, which is continued pre-training. But in all other, and that will be a very small percentage of use cases where a customer would have that much of data. But in all other situations, it is always advised to start with SFT, which is supervised fine tuning, where you have labeled data. You can choose from parameter efficient or full rank, and maybe start with parameter efficient and move to full rank. So parameter efficient is where only adapter is being changed, while full rank is where actual model weights are also getting updated. And then alignment could be an added feature with SFT. So it could be post SFT. You can do alignment to make the model answer questions more closely to what a human preferred answer would look like and what human preferred not would look like. And that's why generally recommendation to like 90% of the use case would be to start with SFT and maybe add on alignment on top of it. But Karan, feel free to chime in if you have other thoughts.
No, that's a good explanation, right? But also, like, I also want to connect back to something that you had said initially, right? Like going back to like the public benchmarks argument, right? Even when you are doing customization, right? If you think about like what is step one, right? It's like trying to sort of understand whether you need to do customization and how much of customization you need to do, and how do you go about that, right? So, evaluation is like the most critical part in all of this, right? Or the step one, or the ground zero, if you want to call it, right? So it's almost become like one of those gotchas where sometimes we've spoken to customers who don't have that evaluation test set just as yet. So I would say, like, as step one, create that evaluation test set, because essentially that is your success criteria, right? That's what's going to tell you whether the foundation model is actually good enough for your specific use cases or not. So I would say, like, start there, create those evaluation test sets, then evaluate these models, because at that point it's more of a, you do the error analysis to try and decide, okay, how do I proceed from here? You may, on the evaluation side, you may get a 70%, you may get an 80%, you may get 85%. Now, once you have those results, you create like almost what you call like a bridge plan, right? So the next step of that is doing some sort of an error analysis to see where do I go next, right? So you look at there were some responses that were successful, some responses that were failures, right? And depending on what that sort of error analysis tells you is sort of how you proceed going down the pattern Anupam mentioned, right? Like if it is just about sort of tweaking the output behavior, you can, maybe start with alignment. But at least what we're seeing more common is just on the supervised fine-tuning side of things, where you really want to like tune the way the tasks are being performed in itself, or some combination of supervised fine-tuning plus alignment. But if you're operating in specific domains where you have a lot of data that could benefit just more generally these models, then yes, pre-training is an option to pursue as well.
Amazing. Yeah, and I guess before we get into the specific fine-tuning and training options that are available, we have a couple of cool questions come in, and I think it's relevant to what you were just mentioning is like foundationally, but you before you're ready to take the step of a lot of customization, you probably need to figure out what's our practice around hygiene of developing quality data sets, right? That's existing test sets that can become a foundation for a fine-tuning data set. And I even see customers have to go in and annotate like wrong responses of models to resolve them with the correct answer to build that training set out. And so a question that comes from the audience oftentimes is just like where to begin in terms of that data collection and building that test set. I've seen customers use take basically invocation logs and then use that as a foundation to getting that started if you're very, very early. But hopefully customers that are looking at things like fine tuning have implemented some basic evaluation frameworks already that they can be that a lot of people don't realize serve as a foundation, that evaluation set for what can later become your data set that you're actually training on. Speaking of, holy moly, what are all these things? What is a DPO? What is PEFT? There's a bunch of different things floating around and ways that we can do it. Right off the bat, I looked at this slide. Clearly, the main takeaway is it looks like you can just about do it all between Bedrock and Sagemaker, but it looks like we're coming with a lot of different capabilities available in this launch, which is awesome for an initial launch of something like, or initial GA of something like this.
Right. No, exactly. Right. Like, so this is essentially going back to what we were saying is like we've essentially provided the full stack, right? Like the full suite. If we look at across the model development life cycle, going all the way from pre-training to fine-tuning to alignment, as we were talking, essentially we want to make it easy for customers to be able to customize Nova, right? So as part of that comes the diverse set of customization options to inject the kind of proprietary data that you would want to for the kind of problem that you do want to solve, right? So essentially, when you think about the continued pre-training, we talked about that. In supervised fine-tuning, we talked briefly about that, like for the task-specific optimizations. Alignment, essentially what we have today is two sort of techniques. One is the direct preference optimization, or DPO, or is the proximal policy optimization, or PPO. DPO is a little bit similar to fine-tuning in the sense like, fine-tuning, you say for this kind of input, give me this kind of an output. It's more literal in that sense to like teach it the specific tasks, right? DPO is a variation of that, but more on the preferences side of things. Now, what does that mean is it's not a binary, this input, like this output, or like give me this kind of an output. It's more for this kind of an input, I prefer this kind of an output, and I actually don't prefer this kind of an output, right? An example of that could be, say you're working on a summarization task, right? And you prefer crisp two-sentence responses as opposed to like a verbose paragraph, right? So you could give like a preferred versus not preferred comparison of that. Or it could be, you may prefer numbered style summary and instead of bulleted style, right? Like, so those kind of preferences is what you can give it as part of the DPO. So going back to like, why do alignment or when to do alignment, it's more, the model kind of knows how to do the task, but you just want to optimize the way the output is sort of coming together. So that's where something like your DPO comes together. PPO is a variation of that, or a more advanced variation of that, where instead of literal data strings like that, you use what's called a reward model to sort of do that kind of an optimization. So it's a more complicated or more complex scenario when you would use that. So some places where we've seen our customers use this is, where something like a content moderation is important to them, and they have like a set of policies that they want these models to like adhere to, then we've seen them use something like a PPO to do something like that. But essentially DPO and PPO are two variations of that come within the bucket of alignment in itself. Now, going back into your question of like, what the heck is it best, right? So in both of these scenarios, right, the supervised fine-tuning and the preference optimization, we essentially have given customers two options, right? I know we said that this is a little bit of the model customization side of things, but we do have a parameter efficient flavor for these specific recipes, and we have a full model training flavor of these recipes as well. What that essentially means is if you use the full model training variation, you can essentially tune the parameters of the entire model, right? Like, so you're actually tuning and training the model in itself. The parameter efficient variation, now the full model variation is great if you have a ton of data, but not everybody has a ton of data, and not everybody may have a large budget to train with a ton of data too, right? So parameter efficient is almost like a low cost. It shouldn't be low cost because we've still seen a lot of effective stories, and we get a little bit more into that. But it's more, if you have smaller samples of data where you don't want to risk like forgetting a lot of the model in itself.
Yeah.
What you can do is instead of tuning the full model, go ahead.
No, it's good. I was just going to say, I love a word you used a few times, and I don't know if we'll cover it in your demo, Anupam, is recipes that we're actually shipping. Not like, obviously it's great that we have these capabilities, but what I've seen customers get excited about is when you can send them the notebook and be like, here's how you do it. And so I just wanted to call out that that's a kind of a companion component of this release that's really helpful for those data scientists that are out there. And we got a few other interesting questions. This is a great question from the audience. Is like, Ritu effectively asks like, where's a good place to start, right? Like maybe what could be of some of the options that are available. What's a way to get a really fast time to value for somebody that wants to maybe launch an initial experiment or do some of their first fine tuning jobs with Nova?
Yeah, I mean, I would say definitely if you have labeled data and you want like first experiment that I should run to see some value, start with parameter efficient fine tuning. It's easy, it's quick, it gives you result in less than 5 hours, depending on data size, but like a data size of less than 5,000 records should give you, and you will see the gains already. And you can host it on demand inference, so you don't really pay for hosting on Bedrock either. So I would definitely recommend to start with that.
Amazing. Good to know as a starting point. Do you want me to pull back up, Karan? You want to talk through any of the customer examples? Are we able to share any of those on the stream today? Oh, and you're on mute still. Apologies.
Sorry. Yeah. No. Yeah. We can talk about it. Talk about it a little bit as an example. I can run through them fairly quickly, and if there's any questions.
Yeah, let's do that, because I feel like the specific reasons people are fine tuning I feel like really helps paint the picture for folks, and then we can get into the Anupam's piece here. But I'll pull up the first one for you.
Yeah, thanks. So let's use MIT, right? There was Boston, no preference there. But let's
we
use
might be
MIT
biased
as
on this one. Yeah.
But let's use MIT as an example, right? I think this is there's the reason I really like this example, right? But it's a really nuanced and unique use case where it's not about the public benchmarks, right? At this point, I think this one really drives home the point that it's not everything's about public benchmarks. So what MIT was trying to do, this is specifically the metamaterials lab under the computer science and AI labs out here in Boston. What they were trying to do is they were trying to sort of create a custom LLM that they can use for advanced scientific research, right? So what they wanted to do was what this lab is they conduct a lot of metamaterials research. Essentially what that translates into is you can think about the next material that is used to produce the next generation spacesuit, right? That astronauts might wear. So that kind of research, right? So it's at the absolute structural level. So it's a combination of code, scientific nuanced understanding, and sort of generating cellular metamaterial designs, right? In the code structures format. So what they were able to do with the combination of SFT and DPO is sort of take the two metrics that were critical to them, and a lot of these examples you will see focus on the metrics in itself, the lift that they saw. This is also why I just want to put a plug back in for why evaluation test sets and having those is really helpful, right? Because this is essentially your success criteria, right? It's not a public benchmark, it's your business specific benchmark where this is how you measure how results matter. So what they were able to do is sort of, the two metrics that were important to them for valid material generation, and then also reconstruction tasks, they were able to go from a 2.7% to a 97.5 success rate, right? That is the power of customization right there, right? You're not talking
this
70%,
is, by the way,
80%.
I just got to say, when I saw this stat, it kind of changed the way I think of this, right? Because I'd really only assumed you might use something like this to take something that a model's decent at already and then take it up to the next level of accuracy. But what this tells me is that you could actually take something a model knows nothing about, that maybe this wasn't in the FM's training data set at all, and make it to where it can now reason and complete over a net new task, which I feel like I've heard that before, but seeing this stat stuck out to me of okay, basically the model was useless at this at 2.7%, and now it's up to 100%. So that's got me thinking about, are there problems that people aren't solving with models today because the base models are so incapable of them, but with a little bit of fine tuning, you could actually maybe expand what you think is possible in terms of use cases,
And this is a kind of success, I think you said it right? We've seen this kind of success where, it could be a matter of going from a 70% to a 90%, or in this kind of a case, it's 2.7% to 97.5%. And these are kind of use cases that I think you said it really well, where people may not even be thinking about, but that's why customize Nova, right? And just in this particular use case, it's almost the outcome of it was for something which is so complex, where you need a PhD for it. They've sort of not only made it easier for their own doctors and scientists to be able to sort of use an LLM to sort of for the scientific research and just iterating off of it as well. But the idea that an LLM can assist with something like this, it almost reduces the barrier to entry for this kind of research as well, right? That's sort of the direction that I can see this all trending in.
Amazing. Yeah. Maybe like if are there any highlights from other use cases that you wanna walk through? Otherwise, I think we'll switch over to the demos here in just a second, just for the sake of time. But any other top of mind things you feel like the audience should know about of projects or results you're working
Yeah,
on?
I think we have like three more results. I can quickly go through them just to hit like the
Yeah.
highlights of them. So Volkswagen Group, what they were trying to do is sort of create a LLM judge that sort of understood their brand-specific behavior, so that as they generated marketing content, they had an LLM that could almost be like the first line of defense. As part of the beta that they participated in as pre-launch, they were able to create a model and show like almost a 15% absolute improvement on the benchmarks that matter to them to identify on-brand images, right? Like, so these are images that on brand for that specific company. So it's not like a general purpose evaluation. So you go to the next one, talk a little bit about Cosine AI, which is essentially they're trying to build a self-sufficient agentic AI software engineer. Cosine AI is doing some incredible work out there for, they're trying to autonomously handle some of the busy work that goes in there. Through fine-tuning Nova on AWS, they were essentially able to create like a custom Nova model that outperformed all other models on AWS. So, and going back to the Nova's price performance, once you're able to do that, you're essentially able to see the kinds of ROI on your investment that you previously wouldn't have been able to see. And then just to almost close it, like not just external customers, but internal Amazon businesses are customizing Amazon Nova as well. So Amazon customer service, the kind of support use cases. This is a combination of multi-turn tool calling and response generation and also intent detection to sort of solve the customer service kind of a problem. They were able to see, meaningful gains on the custom Nova model just through simple supervised fine-tuning as well. And like Anupam said, once you do those kind of an experiments, like a next step could be, if you have the data for it, to try and pursue continued pre-training as well, to just imbibe it with more of the domain-specific knowledge too.
Wow. So broad applicability is what I'm hearing, in a technique that can be applied anywhere. Amazing stuff, folks. If you have questions for the team while we have them live, about any of the new launches or capabilities of Nova, maybe you have a use case that you'd like to run by the team to get their take on, throw it in the chat. We'll be monitoring that for the next little bit while we're live here. And I think, Anupam, you might have a demo. I don't know what TSF. What are you going to show today?
Yeah, so I'll basically walk you through, like, some questions were how to get started. So I'll walk you through what getting started material we have, so you quickly can get started, all the sample codes we have, and then I'll walk you through actually triggering a Sagemaker job using fine-tuning, and like how the overall process looks like, how you can how you can use on-demand inference to make it inference on Bedrock. So yeah.
Amazing. Well, I'm ready when you are. Just pull it up and we'll get it up on the screen and
Awesome.
and let you take it away.
Okay.
Awesome.
Yeah, so basically, first and foremost, all of the content that we are showing can be, or some form of can be found in our GitHub repo, Amazon Nova samples. We can obviously link it in our podcast later as well. But the main idea is we have training jobs and Hyperpod, and we have various getting started notebooks for different techniques that you can pick and choose, DPO PEFT, SFT with PEFT, or FFT, which is full rank fine tuning. It kind of walks you through an end-to-end journey of like data prep to fine tuning to evaluation to hosting it on Bedrock. We also have Nova LLM as judge and a lot of different cool assets we have here. We also have launched a CLI utility for training jobs, which is pretty awesome. It's an experimental preview, but I would love to see people try it out. It's basically a command line tool to kick off your job with just one command, as long as you have the data and everything prepared. Or there are different helper command lines for preparing your data or tuning your model, and various other modules that you can experiment with. Second question around assets is all the recipes. So this launch comes with a bunch of recipes that you can take as is, use as is, or you can tweak around based on your use case, based on your data sets that you're working on. So you can see a bunch of different models and different techniques. So like this means it's a Nova Lite use case with a DPO. This means NOAA Lite with a LoRa-based DPO. LoRa is nothing but another name for parameter-efficient fine-tuning. So you can quickly go through one of the recipes. It's a YAML format. You can tweak around. For example, you can supply your training data, your output bucket where you want to store the assets after the training. You can tweak around like things like epochs or dropouts for regularization if you are overfitting or not. And then bunch of different parameters that you can play around with. Again, there are documentations which can help you understand which parameter to tweak around when. But yeah, this opens a lot more avenues for not just different techniques, but also different parameters that you can tune when compared with Bedrock customization. So yeah, hope that gives some idea.
And
So,
I just
Trevor,
want to say, like, I don't know if your team was involved in these recipes, but I've been on 3 calls with customers now where we've showed them these recipes. First, it was for the Llama models whenever they were available, and then after the Nova models became available, we showed it. And like for data scientists, this is gold because now all they have to do is drop in their data set and they can start running experiments. And so I can't stress enough how great of a resource this is that we have all these techniques documented, so you can just start experimenting.
so Trevor, just to build on that as well, right? Like it actually is for any persona, right? So if they're going back to the YAML file that Anupam was sharing, it's as simple as just pointing it to your data set if you want it to be, or it could be, or you could have the kind of control as much as you want, right? Like, so your first run could be simply pointing an S3 path to the data and hitting run. But if you want to sort of iterate more and more and like sort of want to make tweaks to, be it the LoRa parameters or be it the number of epochs you're training with, or just some more granular configurations of the training loop in itself as well, you have the control here, right? So
Yeah, sounds good. So let's go to let's open a SageMaker Studio, which is just one of the ways you can start fine tuning. You don't need to go to console. You don't need to come to SageMaker Studio also, but this is one of the options that we offer. At the end of the day, what really matters is are you hitting the SageMaker APIs? Because all of the fine tuning is controlled through SageMaker APIs, whether you're hitting through your local IDE or through SageMaker Studio or through Notebook Experience. All of the platforms really work for these things. So I can quickly open a SageMaker Studio. Let's say I click on the personal space. I come here and I find the SageMaker Studio. If you are familiar with it, you might already know this platform. There is also Jumpstart, which is SageMaker Jumpstart. If I click on Jumpstart, I'm actually seeing different NOAA models here already published. So I can click on, let's say, NOAA Micro. I want to customize NOAA Micro, for example. I can read about different techniques available, different strategies. So there is a training job experience as well as hyperpod experience that you can pick and choose. There is, again, the same links that we talked about, GitHub repository, documentation links, all are in the same place. And the coolest thing is, let's say I want to customize. So I click on customize, then it gives me all those techniques that are available for micro model. It gives me the LoRa, which is the parameter efficient fine tuning, the full rank fine tuning, the full rank fine tuning with direct preference optimization, and the LoRa fine tuning with direct preference optimization. It also gives me the reinforcement learning for like PPO and also continuous pre-training. And all of this, it also tells you how much context window it can be trained for, what is the instance type you need. You can look at the format, like how should your data be formatted, if you have only text use case, or if you have image use case or video use case. And also like GitHub recipe link directly. So if I open this link, this directly takes me to that recipe for micro model. So it's kind of one place for everything that you have, which is pretty good at developer experience. So let's say I want to do a LoRa-based fine-tuning. I click on that and open a sample notebook. It gives me 2 options. It gives me, do I want to use training jobs or do I want to use Hyperpod? Let's go with training jobs, and I can choose one of my Jupyter Lab spaces, and it kind of opens up a brand new notebook which is constructed on the fly based on all the information that I provided. So I provided micro, I provided LoRa-based fine-tuning, and it kind of gives me a brand new notebook which is already written with the code, so you don't really have to do much. You come here, you put your different parameter values, like where should your data be picked up from, where the output should be stored, is there a validation data that you should be providing, what image URI you should be using, and then you just kick off the training and start with your process. So it's as simple as that. I can quickly take one more example of one notebook that I have already executed. So we are not training on this call, but actually showing what it takes to train. So here I have provided the recipe path. So this is the recipe path from the same recipe location that we will be using. So in this case, I am using Noah Lite with LoRa-based fine tuning. And I have my data set prepared. So this is the image understanding data set. So let's quickly open the data set to see what it looks like. So the data format is something like, let me open it in editor so that you can see it. So one data point looks like this. So what that means is I am basically providing a Converse API format, which is something like this is a Converse API format. It has the user role and then the content where I'm providing page one and then passing an image, a PNG S3 location of the PNG image. I'm passing my user prompt, which is like basically asking it to process all the information from that image, which is invoice kind of image, and it is asking it to extract details in a structured output. So it's giving a JSON format that it should follow when responding back, and all the data points in this file corresponds to something like that of a format. So that's pretty much very similar or exactly similar when you do Bedrock customization. So if you have already tried Bedrock customization, you can easily use the same data set to start off your SageMaker customization also, if it is the fine-tuning approach. But if it is like direct preference optimization, then there are some nuances that you can also incorporate, like what is a preferred answer looks like versus what a non-preferred answer looks like. Um, Going back, then I provide those S3 locations where these JSON ELF format files are located. So like the training data, where the output should be located, which is the output, the validation data, where should the validation data be picked up from. What it is basically meaning when I say validation is that this data will be used after every epoch to validate if your model is overfitting or not, or it is being generalized enough or not. Then I pass image URI. This is essential to pass. Again, it depends on different techniques. So for example, if I'm using supervised fine tuning and I'm using SageMaker training job, my image URI would be something like this. Again, all these details are in docs, so you should have them pretty handy. And then I'm also using TensorBoard. So TensorBoard is something like a visualization tool where you can visualize your training as it is proceeding. So you can see like the training loss curve and analyze, is my training generalizing enough or is it overfitting? And based on that, you can make a decision of like what hyperparameters should I be changing or what things in my recipe I should be changing. Next is I kick off a estimator job. So what estimator is doing is it's a PyTorch estimator that we are using. I provide all those variables that I defined above in this class. So image URI, the role I will be using, instance type, the recipe I will be using, where should the output go, and what TensorBoard output should go. And then I am using my training input, which is nothing but providing the training data S3 URI and creating like a training input channel. And similarly for validation, creating a validation input channel. And then supplying both the training input and validation input to my estimator.fit. So essentially, this is the line, this is a singular line that is kicking off your training job. It needs training input, validation input, and the estimator defined. And that's pretty much it. And it kicks off your training job. It generally takes 3-4 hours to complete, again, depending on data size. But like for a 5,000 data point with a LoRa-based technique, it should not take more than 5 hours. So we start, and as the training progresses, we start seeing logs here. Again, we start seeing logs in the CloudWatch logs as well. We start seeing logs in the SageMaker training job logs as well, and in your notebook as well. So this kind of goes like it is downloading the data, it is downloading the image that you provided and kick off your training job. And you can also see the loss that it is printing at every epoch, at every stage of the epoch cycle as well, like the training loss curve, and also the samples per second that it is consuming. And this goes on, and then in the end, you see the message of training job completed, which indicates that the training is completed and the model is stored in a Amazon managed S3 bucket where the model gets stored. And once you have the model, then you can obviously look at the training loss curve and make a decision to retrain or to change some parameters or to change the data distribution. Again, those questions come once you do one experiment to figure out how can I further push the boundaries of the model. But yeah, and then you can see the details about your training job here, and you can do further experiments if you want. Now, let's say you have done a couple of experiments and evaluated your model, and you want to now host it on Bedrock. Now you can basically use two main APIs to do that. So it's a two-step process. So the first is create custom model API. What this will do is it will take the model from S3, escrow S3 bucket, which is an Amazon managed S3 bucket where the custom model is stored, and move it to Bedrock. And so this is basically creating a Bedrock custom model from the custom model that you created. You just provide that S3 URI where the model is located. You can find it in the checkpoint config S3 URI. And then you call this method, and it moves it to Bedrock. So it creates some custom model in Bedrock. You can do a get custom model to see the status, and after a point of time, it will become active, and you can see that the model is now live in Bedrock. Once it is there, that means it has moved to Bedrock, and now you can host it. And by hosting, you can use this API, which is create custom model deployment for on-demand inference, which Karan was talking about as well. So you can use the ARN of the model that got that was moved to Bedrock, and basically create a custom model deployment for that using create custom model deployment. And then you can list the custom model deployment till it becomes active. And once it is active, you get an ARN of like your custom model deployment. Now, this ARN is basically what you use as a model ID when you call or when you make an inference call through Converse API or Invoke API. So in my inference, now I'm passing that custom model ARN, which was just created to make any Converse API or Invoke API call, and I get the response. Now the response is actually coming from the custom model rather than from the base model. You can easily switch it back to base model and do like a before and after comparison of how was the model performing before customization and then how it performed after customization. Again, on demand is really a good option, and somebody said to me other day that with on-demand inference there is no reason not to customize, because with customization you will improve some percentage base points, and with on-demand inference you get that kind of for free because it's not charging you anything for hosting. It's exactly the same price as the base model, so there is no reason not to customize now. Especially on the parameter efficient or LoRa based techniques, because that is yeah.
That's a great call out, because I feel like cost, up until now, cost has always been the objection, or has often been the objection, I should say, around this. And there's certainly still some like operational rigor that teams need to figure out in terms of like building out a practice to customize models. But the compute cost should not be a hurdle, right? At this day and age, because you're already paying as much, maybe more, for equivalent base FM inference. So I think that's such an exciting advancement that is cool to see us being on the bleeding edge of here at Amazon in this world of model customization. Hey, we've only got a few more minutes, so I want to open it up. If anybody in the audience has last minute questions, now's your time. We had some great friends. I'll call them out. We have Jabasoft's been hanging out for a while. We got Ritu. If you're still in the chat, you all have had some great questions. So we'll give you a couple minutes to ask any final questions. But Anupam, Karan, I want to say thanks for taking the time today, especially for staying in the office till 7:30 p.m. Boston time for a live stream for the audience here. Much appreciated. And for those folks who are here live, this will go live on YouTube under the same title tomorrow, so you can check out the on-demand recording there. While we wait for questions to come in, though, any parting comments or words of wisdom to the customers and folks watching out there that want to take that are starting to take this model customization journey?
I think Anupam said it well, right? There's no reason left not to customize Nova, right? So I would say create those evaluation test sets, see how these models are doing on your business-specific use cases, and sort of start pushing the boundaries of accuracy with Nova on AWS.
I think that just about says it all. Thanks a lot, gentlemen, for coming on. It was great having you on again for a second time. Anupam, hopefully it won't be the last. I'm waiting for another great new Nova launch to get you all on here again in a few months. But again, appreciate you sharing the knowledge and time with the audience here. And everybody, we will catch you the same time, same place next week on the AWS Show and Tell show. Next week, I think we're talking about Agent Core. Okay, maybe. So stick around. So tune back in same time next week. But thanks, everybody, and enjoy the rest of your nights.
Thank you.
Thanks.